Okay, hi, good morning everyone once again. Today again it will be another tutorial on your trigonometry. So I think we've already discussed in the previous two tutorials the basics that we require to solve questions in your trigonometry, the initial, the basics that we need, okay, so that we can solve questions in a section A. One entire tutorial was on the conversion. That means how are you supposed to go ahead and start the sum. We need to go ahead and make the necessary conversions of the tan, the cosec, the sec and the cot in terms of your sine and cos. Then we also taught you how to find the LCM of trigonometric terms in the basic. Then we moved on to the section A sums, how we apply those basics, and then we do sums in your section A questions. Now in this tutorial, it will be again another type of sum in your trigonometry where we will be solving questions where we have to take the help of the formula called a cube minus b cube. So let's go ahead and show you a few questions where we will use these formulas to solve questions on your trigonometry. So we have a formula that is a cube minus b cube. Now a cube minus b cube, we have two formulas. So one formula we have as a minus b whole cube plus 3ab bracket a minus b. Now this is what you'll have to remember. That's the first formula. And then we have one more formula for your a cube minus b cube. We have another formula that is a minus b bracket, and then the other bracket you'll have a squared plus b squared plus ab. So these are the two formulas. So you'll have to remember both the formulas because according to the question that has been given, we'll have to use either this formula or this formula. And then supposing if someone gets confused as to how do we identify which formula are we supposed to use in which sum. Okay, because see, if I have to use this formula and if I happen to use this in the sum, instead of using the first one, if I use the second one, then it becomes very, very difficult to go ahead and prove the following question, what has been given to us. And instead of using this, if I use this, again there will be a problem where you'll not be able to prove the left equals to the right. So how do we identify? So one very, very easy technique is there to identify which formula are we supposed to apply in the formula. So let's say, for example, if this is the question, okay, though it's not given in a cube, we'll go ahead and show you how to go ahead and convert these also in a cube. But the moment, let's say, for example, supposing if this is a cube question, okay, and the moment anywhere in the question, if I see a 3, okay, if I see a 3 anywhere in the question, that means I know I'm supposed to use this formula. Though I see a 6 over here, but we'll show you how to convert this into a cube form. But in the question, if I see 3, any 3 mentioned in the question, I'll have to use this formula because this is the only formula which has a 3 mentioned. Over here there is no 3, so if I see something like this, I'll have to use the first formula. Whereas if I see a question like this where I have a cube minus b cube, or in the form of a cube minus b cube, but nowhere in the question I see a 3. So I don't see any 3 anywhere in the question. So if I don't see a 3, I know I'll have to use the second formula. So at least the identification part is most important first. So you need to know which is the formula that you need to apply. Now once we know that, okay, this is the formula that we have to apply, let's show you how to apply. So the most important thing is look for a 3 in the question. If I see a 3, I use the first formula. I don't see a 3, I'll have to use the second formula. Okay, so first let's start with this one. Or let's start with this one. This is a lot more easier. So if I have to see this because this is already in a cube form. Now this one is not in a cube form. We'll have to first convert it in a cube form. So now this is already a ready-made. So I don't see any 3. I'm supposed to use this formula. Okay, so now if you compare the two formulas, in the numerator I see a cube minus b cube, so it looks like this. The only difference over here is over here I have a, but in the question there is no a. Instead of a, I have a sine theta. So that means a in the formula, wherever I see an a, over here in the question, the a has been replaced by my sine theta. Similarly, wherever I see a b, the b has been replaced by my cos theta. So that much you should know, that I don't have literally an a and a b, I have a sine and a cos in the question. So in the answer, when I'm applying the formula, I need to make sure that wherever I have a and b, I need to replace it by sine and cos. So when I apply the formula, what will happen from here? So a cube minus b cube, sine cube minus cos cube means a minus b. So a over here is sine theta, so I put a sine theta, and it's minus, as per the formula I put a minus, and the b is a cos theta. A minus b, sine theta minus cos theta. Then you have on a bracket over there, it says a square. A is what? Sine theta. So I have sine square theta because sine a is sine theta, so a square becomes sine square theta, plus is a plus, you have a b square over here, b is cos theta, so if I square this it becomes cos square theta, and then it says plus we have an a b, so a and b, so together I get sine theta cos theta as my left hand side, and then it's the right hand side, it says 1 plus sine theta cos theta. So now, oh sorry, this one, the denominator is also there, so the denominator I write it as sine theta minus cos theta. Okay. So what I've done is I applied the formula a cube minus b cubed over here. So a cube minus b cubed, because I don't see any 3 in the question, I know I'm supposed to apply the second formula. So over here in the second formula, we have first bracket is a minus b. So a over here is sine theta, b over here is cos theta. So first bracket is a minus b, we write sine theta minus cos theta. Then the second bracket is a square. A is sine theta, we write sine square theta. We have a plus, we put a plus. B is cos theta, so we put cos square theta, and then plus AB means this two getting multiplied plus sine theta cos theta, and the denominator is a sine theta minus cos theta. We write this. So that's the left hand side. Okay, now what happens is, now if you look carefully, look at this entire group and look at this entire group. These two groups are exactly the same. So when they're exactly the same, these two groups will get cancelled out. Okay, so once they get cancelled out, then the remaining I have it as sine square theta plus cos square theta plus sine theta cos theta is what is left, because this entire group and this group, they are matching. So once they match means they can be cancelled out. And then now if you look closely, we have sine square theta plus cos square theta, and then we have these formulas I think we discussed in the previous tutorial also. Sine square theta plus cos square, if both of them have a square and if there's a plus in between, we can replace it by a 1. So we know that sine square theta plus cos square theta is equals to 1. So I can replace these two as a 1, and I can write a plus sine theta cos theta. So now if you match this answer with my right hand side, they look exactly the same. So that's how it's proved. So we don't have to do anything, we just have to apply the correct formula, and just within 2 steps I think we will get the answer. Okay, so first thing is check for a 3 in the question. If there is any 3, I have to apply the first formula. Right now I don't see any 3, I need to apply the second formula, and then this is how we apply. Just compare your formula with the question. So whatever is the cube, that becomes my A, and then whatever is the second one, that becomes my B, and then accordingly apply. So that's how we apply the second formula. Over here it was good enough because it was easy also. Why? Because directly they were in a cube form. But now if we have question like this, where right now this is not in a cube form, then how do we convert something like this in a cube form? It's this. Okay, so let's say for example, if I have anything like, if I have A10, okay, or not A10, let's say I have, let's say A15. If I say write this in a cube form, so make this in something cube. So all I have to do is, I want in a cube form, so what I do is I write the 3 outside because I want in a cube form. So I'll have to write something cube. So what will be inside? 3 into what will give me 15? So 3 5. So indirectly it is like a to the power of 5 cube. So it will be this cubed. Okay, that's how we make it in a cube form. So if I have A24, then if I want in a cube form, I write A, I write the cube outside, and 3 into what will give me 24? 3 8s are. So that will be this cubed. Okay, that becomes the base and that becomes the power. So if I have, let's say A6, if I say convert this into a cube form, I write the A, I want the cube, and I write 2 over here. Okay, so that's how we go ahead and convert any number into a cube form. Okay, so like if I have A6 minus B6, if I say convert both of them in a cube form, so then it becomes what? A, and then I want the cube outside and I have 2, minus B, I want the cube outside, I have this. So it looks like this is A cube minus B cube. So the entire thing, I'll take it as the first and I'll take this as B. So my formula says this one. So supposing for this one, if I have to apply this formula, then how do we go about doing this sum? So over here, this entire bracket is called the A and this is called a B. So the first bracket is A because this is called your base. So this becomes this cubed minus this cube. So now over here in the formula, we have A cube minus B cube. So we have the cube, and underneath that, whatever we have, we take that as A. So this is the cube. Underneath that, whatever we have, we take that as the A. So it says A minus B. So I'll write it as this becomes A now, minus this becomes a B, and then we have a cube plus 3AB plus 3, and then we have an A and we have a B, and then bracket A minus B. That's how we go ahead and apply the formula for this one. So that is how we convert any given number into a cube form. So all we have to do is write the cube outside, and then whatever is that means the value with which it gets multiplied, that gets inside. That means if I have 15, then 3 into what will give me 15? Whatever is that value, it stays inside. And this entire thing, we take it as the base, or we take that as to be an a. So 3 into 2 gives me a 6. So a square is considered as a for this particular question. So similarly, now if I have to solve this, so what will I write it? So this is 6. If I want to convert it in a cube form, so I'll write it as cosec, and then I write a cube, so it will be 2 cosec square cubed. So minus, what will I write over here? I'll write cot, and I'll write this cubed, and this right hand side as it is, I copy it. Okay, so now this looks like a cubed minus b cubed. So over here, what is a? A is my cosec square theta. Where what is my b? B is my cot square theta. So as per this question, so this entire bracket is taken to be as an a, this entire bracket is taken to be as a b. So wherever in the formula I see an a, I'll put cosec square theta. Wherever I see a b, I'll put a cot square theta. And then I know I have to apply this formula because I saw 3. I need to apply this first formula. So when I apply the first formula over here, it says a minus b. So a minus b is cosec square. This is a minus b, and then we have a cube. We write a cube plus 3ab plus 3, and we have a, we have b, and then bracket a minus b. That's the left hand side. So we are doing the left hand side right now. Okay, but now once I get this, so you need to be aware of a few extra formulas also. Just like sine square theta plus cos square theta, we have an answer as 1. Similarly, there is a relationship between sec square theta and tan square theta, like sec square theta minus tan square theta is 1. Similarly, we have cosec square theta minus cot square theta. So if I happen to get something like this, I can replace it by a 1. I can replace them also by a 1, just like I can replace this by 1. So in the question, I see cosec square theta minus cot square theta. So cosec square theta minus cot square theta is equals to 1. So we write this as what? 1 cubed plus 3 cosec square theta, cot square theta, and then again this entire thing, we have cosec square minus cot square. We can all again replace it by a 1. So 1 cubed is 1 plus 3 cosec square theta, cot square theta. So and if I compare this answer with my right hand side, I think we have got the same answer. Okay, so that's how we go ahead and apply the cube formula to prove. So if I know my formula of the cube plus I know an add-on formula of this one, then it becomes very, very easy. We just have to apply them and then get the answer. Okay, let's go ahead and give you one more example. Let's do one more example of this type of sum. So let's say, for example, we have something like this. Okay, so let's say the question says we have sec 6 theta minus tan 6 theta, 10 to the power of 6 is equals to 1 minus 3 tan square theta plus 3 tan to the power of 4 theta. So if I have this, so if I see 6, first let's go ahead and convert them into cube form. So I write the square inside, 2 inside, and the 3 outside. I write the 2 inside and the 3 outside, and this I copy it as it is. Okay, and then now if you look over here, this is like a cube minus b cube, and if I see a 3, I see a 3 in the question, I know for sure I'll have to apply the first formula. Okay, and the first formula, now if you know already, it is like a minus b whole cube. So I get it as what? A minus b whole cubed, then it says a plus, then it says 3a b bracket a minus b. Okay, so that's the formula. So we have a minus b whole cube plus 3ab bracket a minus b, and the right hand side as it is for the time being. So now we already know that sec square theta minus tan square theta is also equal to 1. So I see sec square theta minus tan, so I write 1 cubed plus 3 sec square theta tan square theta, and this bracket is also equal to 1. So I write equal to 1, and the right hand side I write it as it is, 3 tan square theta plus 3 tan to the power of 4 theta. So when I solve this part, I get 1 cubed is 1 plus 3 sec square theta tan square theta, and that is equal to 1 minus 3 tan square theta plus 3 tan to the power of 4 theta. Okay, so right now I've done this, but if I just compare the left and the right, it's still not matching. So the left and the right is not matching. So now we have applied the formula the a cube minus b cube formula, we have also applied the cube formula also, as well as we have applied the sec square and the tan square. But still right now, in spite of doing all those, it's still not matching. So then if it doesn't match, now you just compare the left and the right. Okay, because it's still not matching, we have to do something extra. So for that, just compare the left and the right. When I compare the left and the right, so if you look on the right hand side, the only trigonometric term that we have is a tan. So though the power and all is different, but we focus only on the trigonometric term. We have tan and tan, only tan. But on the left hand side, I have a tan. Yes, it's fine. We have tan over here also, we have tan. But the extra thing that we have on the left hand side is a sec, because we don't have any sec. So somehow if I replace the sec, and in its place, if I just put my tan, then I think at least we'll have tan and tan. The only trigonometric term on the both sides will be only tan. So I need to just replace the sec, and in its place, let's try and bring a tan. So is it possible? So then we'll have to manipulate this. So sec squared minus tan squared is equal to 1. But if I want to replace the sec square, I can write the sec square theta as, I can take the tan that side, I can write it as 1 plus tan square theta. So I can take out the sec square, and in its place, I can put 1 plus tan square theta. Okay? So I'll get 1 plus 3, and I get 1 plus tan square theta, and then I get tan square theta is equals to the right hand side. So now when I open the bracket, so what do I get? Let's open from the back. It's always advisable we open from the back. You can open from the front also, doesn't matter. So 1 into tan square will give me tan square theta plus tan, and then I get a tan 4 theta is equal to this much, because 2 2s are 4. And then now open this one also, I get 1 plus 3 tan square theta plus 3 tan to the power of 4 theta is equal to this much. So now if you look at this, look at the left hand side, and then if you look at the right hand side also. So right now they are exactly the same. So that's how it's already proved. So that is how we go ahead and do these kind of sums. So what we always have to do is check carefully as to which is the formula that you need to apply. Do you have to apply the first formula, or do you have to apply the second formula? That all depends upon, do I have a 3 or I do not have a 3. If I have a 3, I apply the first formula, like in this case. Sometimes I may not have a 3. So if I do not have a 3, okay, like in this case, I do not have 3 in the question, I'll have to apply the second formula. And that's how we apply. And you need to know add-on formulas of this also. These 3 you need to know, and sometimes you may have to manipulate them also. Okay, so that's it for the time being. I hope you'll be able to solve questions on your cube formulas. So we'll be talking about the other variety of questions in the other tutorials. So that's it for the time being. If there are any queries, please feel free to let me know, so that I can just go ahead and solve those queries also for you all. Okay, that's it for the time being. Thank you very much.